Hello students, in today's lecture we are going to learn about thermal properties of matter. NCERT example 10.7 and section 10.9.2. This is disclaimer. Learning objectives. By the end of this lecture you will be able to understand the concept of convection. In today's lecture we will cover first example 10.7, then 10.9.2 convection. So example 10.7. Question is, an iron bar, length L1 is equal to 0.1 meter, area A1 is equal to 0.02 meter square, and thermal conductivity K1 is equal to 79 watt per meter per Kelvin. Similarly, for brass bar, L2 length is 0.1 meter, area A2 is equal to 0.02 meter square, and thermal conductivity K2 is equal to 109 watt per meter per Kelvin are soldered end to end as shown in the figure 10.16. So look at here, figure 10.16. We have a two bar, first iron bar, second brass bar, and both are soldered end to end. The temperature of iron bar T1 is equal to 373 Kelvin, and for brass bar temperature is 273 Kelvin, and the junction where both iron bar and brass bar are soldered having temperature T0. The free ends of the iron bar and brass bar are maintained at temperature 373 Kelvin and 273 Kelvin respectively. Obtain expressions for and hence compute first the temperature of the junction of the two bars. So the temperature T0, this shows the temperature of the junction of the bars where both iron bar and brass bar are soldered end to end. Second, we have to find the equivalent thermal conductivity of the compound bar. Compound bar means complete bar after soldering. So here we have to find the equivalent thermal conductivity of the compound bar, and third we have to find the heat current through the compounded bar. Alright, here we have find out the three things. First, temperature of the junction of the two bars. Second, equivalent thermal conductivity of the compound bar, and third, heat current through the compound bar. Alright, think about it and please solve. Let's see the solution. So the given terms, length of the iron and brass bar L1 equal to L2 equal to L is equal to 0.1 meter. It means iron bar and brass bar having same length. Alright. Area of the iron and brass bar A1 equal to A2 is equal to A is equal to 0.02 meter square. It means area of the iron bar A1 and area of the brass bar A2 both are equal. So here we assume A1 equal to A2 equal to A. And temperature of the free end of the iron bar T1 is equal to 373 Kelvin for iron bar. For brass bar, the temperature of the free end T2 equal to 273 Kelvin. Similarly, the thermal conductivity of iron is K1 equal to 79 watt per meter per Kelvin. Thermal conductivity of brass bar K2 is equal to 109 watt per meter per Kelvin. So these are the given terms. Using these given terms, we will find our solutions. All right. So first we have to find out the expression for temperature of the junction of the two bars. So we know heat current through the iron wire. The formula is H1 is equal to K1 A1 T1 minus T0 divided by L1. All right. Here we assume H1 because we talk about the first bar, iron bar. Similarly, the heat current through the brass bar H2 equal to K2 A2 T0 minus T2 divided by L2. All right. So these are the formulas of the heat current through iron bar and brass bar. And using the given terms which we already discussed, and put the all terms in these formulas H1 and H2, and you will be get the value of H1 and H2. So now in steady state means the heat current through the iron bar and brass bar will be equal. So we can say H1 is equal to H2 equal to H. So we know the value of H1, that is K1 A1 T1 minus T0, and H2 is K2 A2 T0 minus T2. All right. And we know L1 equal to L2 are equal. Similarly, A1 equal to A2. So junction temperature T0 of the two bars is, so solving this term, you will be get the junction temperature, that is K1 T1 plus K2 T2 divided by K1 plus K2. All right. Now substituting the value of T0 in the expression of H1. So we know the value of H1, that is K1 A1 T1 minus T0 divided by L1. So put the value of T0 in this expression, or we can say in the expression of H1. So you will be get K1 A1 divided by L1 as it is T1 minus the value of T0, that is K1 T1 plus K2 T2 divided by K1 plus K2. Now we know L1 equal to L2, L1 equal to L and A1 equal to A. So it will be become H1 is equal to K1 K2 A divided by L. All right, into T1 minus T2 divided by K1 plus K2. So this is the value of H1. Now similarly substituting the values of T0 in the expression of H2. H2 is the heat current for brass bar. All right. So H2 equal to K2 A2 T0 minus T2 divided by L2. So similarly put the value of T0 in the expression of H2. You will be get H2 equal to K2 A2 divided by L2 into K1 T1 plus K2 T2 divided by K1 plus K2 minus T2. All right. Here we just substitute the value of T0. So we know L2 equal to L and A2 equal to A. The length of the brass bar is equal and length of the iron bar are equal. So we consider L1 equal to L2 equal to L. So we can say L2 equal to L. Similarly A2 equal to A because area of iron bar and area of our brass bar are equal. So we can say A2 equal to A. So just put the value in this expression. You will be get the H2 equal to K1 K2 A divided by L into T1 minus T2 divided by K1 plus K2. Now the next step we will solving this term. So now in steady state H1 equal to H2 equal to H. So we can say H is equal to K1 K2 into A divided by L into T1 minus T2 divided by K1 plus K2. Hence the expression of the heat current is H is equal to A T1 minus T2 divided by L into 1 upon K1 plus 1 upon K2. So the above equation H is equal to this one. We rewrite in simple term to solve easily. Alright. So using the expression of the heat current, that is H is equal to A into T1 minus T2 divided by L into 1 upon K1 plus 1 upon K2. And H prime through the compound bar. H prime is the H prime through the compound bar of the length L1 plus L2 equal to 2L. Because we know the length of the iron bar is L1 and length of the brass bar is L2. Alright. But both length of the iron bar and length of the brass bar are equal. So we can say L1 equal to L and L2 equal to L. So L plus L is equal to 2L. So H prime equal to K prime A into T1 minus T2 divided by 2L is equal to H. So where K prime is the equivalent of the thermal conductivity of the compound bar. So K prime equal to 2 K1 K2 divided by K1 plus K2. Alright, this is the thermal conductivity of the compound bar. Now, using the all calculated terms, we will put the numerical values now. So first, calculating temperature of the junction of the two bars, that is T naught, or we know T naught equal to K1 T1 plus K2 T2 divided by K1 plus K2. So just put the value of K1 T1, similarly K2 T2. So you will be get T naught is equal to K1 79, T1 373 plus K2 109 into T2, that is 273 divided by K1 plus T2. So K1 79 plus K2 109. Alright. So multiplying and adding, you will be get 29467 plus 29757 and divided by 188. So solving this expression, you will be get T naught is equal to 305 Kelvin. It means we can say the temperature of the junction of the two bars is equal to 315 Kelvin. Alright. Now, second, we have to find out the equivalent thermal conductivity. So we already find out the expression, that is calculating the equivalent thermal conductivity of the compound bar K prime equal to 2 times of K1 K2 divided by K1 plus K2. So we know the value of K1, similarly K2, that is given in this question. So put the value of K1 K2, you will be get the thermal conductivity of the compound bar. So 2 into K1, value of K1 is 79 into value of K2 109 and divided by K1 plus K2. So it will be 79 plus 109. So solving the denominator and numerator, you will be get 17222 divided by 188. After division, you will be get K prime is equal to 91.6 watt per meter per Kelvin. It means we can say the equivalent thermal conductivity of the compound bar is equal to 91.6 watt per meter per Kelvin. Alright. Similarly, we will find out the heat current through the compound bar. Let's see. So calculating heat current through the compound bar. So the formula is H prime is equal to H is equal to K prime A into T1 minus T2 divided by 2L. Here K prime is the thermal conductivity of the compound bar. So put the value H prime is equal to thermal conductivity of the compound bar is 91.6 into area, that is 0.02 into T1 373 minus T2 273 and divided by 2 into L, that is 0.1. So solving denominator and numerator, you will be get 183.2 divided by 0.2. After division, you will be get H prime is equal to 916 watt. So this is the we can say heat current through the compound bar. All right. Now 10.9.2 convection. So here we know convection is a mechanism of heat transfer. In previous lectures, we already studied about the conduction. Similarly, here we will discuss about the convection. This is also a process of heat transfer. So let's see the definition. Convection is a way heat moves from one place to another through the movement of liquids or gases. So we can say in the process of convection, there is a movement of heat through one place to another place. But heat moves. But we can say here liquid or gases also moves. Movement of heat. This is correct. But we can say in the process of convection, movement of liquids also occurs. Unlike other forms of heat transfer like convection can only happen in fluids, which includes both liquids and gases, because it requires the physical movement of heated material. So we can say convection can only happen in fluids. Fluids means liquids or gases, because in convection there is a requirement of the physical movement of heated material. All right. So in the process of convection, here the heated material is fluid or gases. Example, water boiling. This is a good example of convection. So when water is heated, look at here, when water is heated, hot water becomes less dense. You know, hot water is less dense and cold water is high dense. So their density is different. So we can say here hot water becomes less dense because of heating, and when water heated, it will moves upward. Upward means suppose look at here, the lower part of the pan. So when we heated the water, so the density of the water is less, or we can say hot water density becomes less, so it moves upward. After heating, it moves upward. All right. While cold water is more dense comparatively. Cold water is more dense and it moves downward. And this process, this cycle continues. All right. Until thermal equilibrium is reached. So similarly, one more example, hot air rising here. So when air gets warm, it becomes lighter, or we can say less dense than the cool air around it. This causes warm air to float upward and just like a balloon. So we know warm air having less density, cold air having large density. So air moves less, after heating, air moves in upward direction like a balloon. So when we filled gas, or we can say when we filled gas in a balloon, and due to less density, it will move upward direction. There are two types of convection. First, natural convection. Second, forced convection. We will learn each one by one. So first, natural convection. Basically, In natural convection, we can say when hot fluids like liquids or gases, when hot fluids rise and cold fluids sink, creating a natural flow. So in that case, heat moves from one place to another. So when a fluid is heated, like figure this one, when a fluid is heated from below, so the uh, particle of the fluid move after heating in upward direction, and cold molecules move in lower part. So direction of cold molecules and warm molecules are opposite. Heated part expands and becomes less dense. So buoyant force causes the warmer and lighter portion to rise. So when we heated a liquid, or we can say fluids, so due to heating the molecules gain energy and it move in upward direction because of less density. All right, and the water molecules, or we can say fluid molecules having high density, moves in downward, or we can say towards the bottom. Colder or denser fluid moves down to take its place. This cycle setups a continuous convection current. If we talk about an example like sea breeze, land breeze, and trade winds. So these are the examples of natural convection. All right. So natural convection in everyday life. First, sea and land breezes. So here we will discuss it in two parts. First, during daytime, and second, during night time. All right. So during daytime. So here question arises first, why it happens. So we can say during daytime, land heats up faster than sea. All right. So air above land becomes hot and expands and rise because of hot air is lighter. So here we can say the sun makes the land get more quickly than ocean. This makes air above and land rise up. The cooler air from above the ocean then moves towards the land and fill the space. And this movement of cool ocean air toward the land is called land breeze. So here this creates low pressure area above the land. So over the sea the air is cooler. All right, so it's high pressure. So we can say cool air from the sea moves toward the land to fill the low pressure area. All right, and these cycles continues. All right, so we can say a cool breeze blows from sea to land, and this is called sea breeze. Similarly, sea and land breezes during night time. So during night time, what happens? The land loses heat faster than the ocean. Now the air above the ocean is warmer. So during night time, the air above the ocean is warmer and rise. And cooler air from the land moves forward towards the ocean. And this movement of cool land and air toward the ocean is called land breeze. So here this movement happen on the land, so we can say land breeze. Now other example of natural convection is trade wind. So here question arises, what is trade wind? So we can say trade winds are the consistent surface winds that flow from northeast toward the Earth's equators. Their formation involves several natural processes, and these natural processes are temperature differences, basic air movement, Earth's rotation effect, final trade wind pattern, and we will discuss each natural processes one by one. So, natural processes of trade wind. First, temperature differences. So, Earth equators receives more direct sunlight than the poles. So here Earth is round. So sunlight does not fall equally everywhere. Yes or no? So equator gets the more direct sunlight, so the air there becomes very hot. And this creates, or we can say this hot airs becomes lighter and rises. So we can say this creates warmer air near the equator and cooler air near the poles. And these temperature differences causes air movement. So rising air creates low pressure area at the equator. Alright. Now, natural process of trade wind. Basic air movement. So hot air at the equator rises into the atmosphere. This creates low pressure area at the surface, and cool air from higher latitudes flows into fill this space. And this creates a simple circular pattern of air movement. So, third is Earth's rotation effect. Alright. So Earth's rotation significantly influences air movement. So Earth is rotating from west to east in this case, and near the equator the speed is 1600 km per hour due to Earth's rotation. Air near the poles moves much slower, and this speed difference deflects in movement of air. Alright. So we can say in the northern hemisphere it gets deflected to the right. In the southern hemisphere it gets deflected to the left. Now, third is final trade wind pattern. So instead of reaching the poles, the rising air descends around 30° north latitude. So hot air rises at the equator having low pressure. Alright, and cool air sinks at 30° north and south. So here the returning surface winds flows from northeast to southeast. These consistent winds are what we call trade winds, and they were historically crucial for sailing ships. Alright, or this creates steady winds from east to in both hemispheres. Second is forced convection. So if we talk about the forced convection, so it is a type of heat transfer that occurs when fluid movement is created by external mechanical devices rather than by natural temperature differences. So here the external factor is mechanical devices. This process is deliberately controlled using equipment such as pumps, fans or blowers. Examples: forced air heating systems in homes. Fans blows heated air through ducts. Human circulatory system. Heart pumps blood throughout the body. So these are the examples of forced convection. Similarly, car engine cooling systems. A water pump circulates coolant through the engine. All right. So forced convection in everyday life. So cooling of electronic components. So electronic devices such as computers generate significant heat during operation. Yes or no? So to prevent these problems, cooling fans play a crucial role. These fans work by drawing a cool air from outside the device. So this one is the forced air convection. Look at here. Forced air convection cooling fans. This one. Inner, there are two movement of two ends of the movement of airs. So circulating this air across the hot components, pushing the warm air out of the device. So warm air pushing from red region. All right. Now, forced air convection in everyday life. Personal cooling. So act of cooling oneself with a paper fan or an electronic fan is a simple example of forced convection. So hair dryers use a fan to blow hot air which dries the hair. So these are the convection examples in everyday life. All right. Summary. Heat transfer by convection occurs through actual movement of fluid particles between regions of different temperatures. Convection can only occur in fluids, liquids and gases, not in solids. In solids, there is a transfer of heat, that is conduction. Natural convection occurs due to density differences. Hot fluid rises less dense and cold fluid sinks due to more density. Sea breezes forms during day. So temperature of the land is greater than temperature of the sea. Land breezes forms at night. So temperature of the sea is greater than temperature of the land. Forced convection uses external devices, fans, pumps to move fluid and transfer heat. Trade winds form due to temperature difference between equator and poles and modifying by Earth's rotation. Omega is equal to 2 pi divided by 24 radian per hour. Air speed varies with latitude. So equator has highest rotational speed while poles have 0. All right. Now here we have some practice questions and these are homework for you. First, what are the three main types of heat transfer? Or we can say three main mechanisms of transfer of heat. We know conduction, convection and radiation. In upcoming lecture, we will learn about the radiation. Second question, why does hot air rise and cold air sinks during convection? So explain both. Explain both. Third, how does convection help warm air up a room with a heater? Fourth question, what role does convection play in the formation of wind? And fifth one, can convection occur in liquids or only in gases? All right. So here you have to find out the answer of these 5 questions. All right. Thank you for your attention.